Okay, so apologies for that brief interruption. We'll see if we can get it to work now. Just a reminder, we've got 4 different kinds of stops that we talked about. One from Quechua, which has a lot of aspiration, or aspiration that lasts for a long time. We've got aspiration that lasts for a short amount of time, about 35 milliseconds. And then in Dutch, we have a stop that has basically no aspiration, but also no voicing. So voicing begins only 7 milliseconds after the release burst. And then we also have in Dutch a stop where voicing begins before the release burst. And this one is what you would consider truly voiced. VOT. So this leads us to the point of the lecture. We're going to define this entity called voice onset time. So some languages contrast between voiced and unvoiced stops, like Dutch. Others contrast between aspirated and unaspirated stops, like Quechua. So Lister and Abramson, way back in the day, came up with this concept called voice onset time that kind of collapsed those 2 distinctions into one continuum, which is something you can quantify quite easily simply by looking at what's going on in the spectrogram. So voice onset time is the length of time between the release of a stop closure and the onset of voicing, exactly those timings that we've been looking at in the previous slides. So for aspirated stops, there's nothing absolute about this. There's sort of general boundaries where things sound aspirated or unaspirated. So for an aspirated stop, voicing begins after the release. That's kind of the one relation which has to hold, but the specific amount of VOT is going to vary depending on the speaker and on the language. So VOT for an aspirated stop will probably be around 50 to 150 milliseconds long. So basically long enough for you to be able to hear it or to pick it up as a listener. For an unaspirated stop, usually there's kind of a gap that's pretty clear between aspirated and unaspirated stops for stop or phonation contrast in a language. So for unaspirated stops, it doesn't normally go up to like 0 to 50. It stops short of that, probably something more like 0 to 20. The example we saw in Quechua was 35 milliseconds. That's fairly long for an unaspirated stop. And in fact, 135 milliseconds for an aspirated stop would be fairly long for an aspirated stop too. So maybe just, I don't know that much about Quechua, but maybe it's that speaker, maybe it's the language that tends to have longer VOT for these sorts of contrasts. But normally, getting back to the point of unaspirated stops, in the ideal situation, you'd see something like we saw for the Dutch unaspirated stops, where voicing begins almost immediately after the release. Kind of just processing, you kind of have to have your vocal folds in the right position, and then as soon as you release the stop, air can kind of flow both through the release burst and also through the vocal folds, and the air pressure difference can kind of make everything happen at the right time. So in that case, you'd have a VOT of about 0 milliseconds. Usually it's a little bit longer than that, like maybe up to 20 milliseconds. For a truly voiced stop, voicing begins before the release, so VOT will be less than 0 milliseconds. And some students have a hard time wrapping their heads around this, but VOT can be negative. So it's, again, the length, VOT is defined as the length of time between the release of a stop closure and the onset of voicing. So if you think about the 0 point, I might actually write this out. Normally I write this out on the board when we're doing this in class. I'll write it out this way. And so VOT in milliseconds, and we'll kind of draw out probably be a lot more exciting to see if you could actually see what I was drawing, but I'll show you in a second. So we'll say this is maybe 20 milliseconds. And over here we have pa, we have ba, and here we have ba. Okay, so hopefully you can make sense of this. So you can think of this as like on a scale. On the x-axis, you're measuring when voicing begins with a relationship to when the release burst has occurred. So if voicing begins right at the same time as the release burst, or maybe just a little bit after it, you get an unaspirated stop, which we're going to transcribe with a P. If voicing begins a long time after the release of the stop burst, 20 milliseconds or more, or maybe 50 milliseconds or more, then he gets an or an aspirated stop, puh, with our little H superscripted there. But if voicing begins before the release burst, it's just our landmark because we can see it easily on the spectrogram and actually hear it pretty easily too. If voicing begins before the release burst, then we have a negative VOT and we get a truly voiced stop, which we would transcribe with a buh. Okay. We've seen a fair number of examples of that in the slides. What we haven't seen an example of yet is the fact that there are some languages like Thai which have this three-way distinction. It's not just two types of stops in the language, they can go with all three. And we've got some nice examples here. And I'll point out, actually I'll play them for you first and then hopefully you can make sense of what's going on. So we'll do the bilabials first.
Ba, ba, pa.
I'll do that one more time.
Ba, ba, pa.
And the alveolars.
Da, da, ta.
So Thai is a tone language as well. The point I want to make is that as English speakers, in onset position, normally the contrast we care about is the contrast between unaspirated and aspirated. So our English boundary in terms of meaningful contrast, this is very poorly written, but I said it, so you will probably be able to understand what I wrote. But our boundary, our meaningful phoneme boundary in English is kind of the contrast between unaspirated and aspirated. So we don't really care. All we care about is whether a stop is on either side of this boundary. We don't really care where it is on this side of this boundary between whether the voicing begins before the release burst or after the release burst. So for a native English speaker, these two stops will actually sound quite similar. And the way that translates in Thai is that you're probably going to hear these first two types of stops as sounding quite similar to each other. So
ba, ba, da, da.
But they mean something different in Thai, right? And the thing you have to pick up on as a phonetician, and maybe a native English-speaking phonetician, or just an English-speaking phonetician in general, is that you have to listen for that kind of low-frequency hum that you get with voicing ba, ba, ba. That brief period of voicing before the release burst here, if you listen closely, you can pick it up.
Ba, ba.
You don't hear it here.
Ba.
You might hear it here.
Da.
Not here.
Da.
Okay, that's how Thai works, which is pretty cool. You can also see this. We've seen it before, but here's our voicing during the stop closure here. Low frequency hum.
Ba.
You don't get it in an unaspirated stop. It's just silence.
Ba.
And here's our release burst for the P, and voicing begins right after that for the vowel. The release burst is kind of hard to pick up here in the voiced version of this, but because it looks almost exactly like a glottal pulse, but that's it right there. And voicing begins, well, it begins before that, but it goes straight through it. So you don't see any aspiration gap. Okay, so this is the funny thing, and I'll write this out here too. I think I gotta grab my tea towel eraser. So English is doing things you don't expect or don't realize based on what we told you in intro phonetics and maybe even the first part of this class. So I'll keep score here as we go, but we have two different types of stops and they manifest themselves phonetically in different forms depending on where you find them in a word. So in onset position, the phoneme P is going to be voiceless aspirated, and the phoneme B is going to be voiceless unaspirated. So it's this sort of contrast, P versus B. You don't normally get true voicing for that B in onset position. However, when it's in medial position, in the middle of a word, then you do get true voicing for that B. You do get kind of the canonical forms you'd expect. So there's no aspiration for the P, but there is voicing for the B. So they look exactly like they are written out in phoneme form. And then the kind of funny part of this is that after an S you get no contrast at all. There's no way to distinguish between a P and a B in that environment. And so what you get there is neither the voiced one nor the aspirated one. You get the voiceless unaspirated stop. So there's no contrast. And I can play you some examples of this, which I've loaded up into Prot. Give me a second. Wait, I didn't load them up in the Prot. Never mind, I had to restart the computer. All right, I'm going to pause right now, load them up in the Prot, and then play them for you in a second.